A periodic function is any function that repeats its values on regular intervals or periods. Think about your breathing, your heartbeat, or the waves of the ocean. These phenomena repeat the same activity as a steady pattern. The most famous periodic functions are the trigonometric functions. Other examples of periodic functions in nature include light waves, sound waves, and phases of the moon. So periodic function, any function that repeats a pattern of y values at regular intervals. The cycle is one complete pattern of the y values for a periodic function. The period is the horizontal length of one cycle for a periodic or repeating function. And the amplitude is half the difference between the maximum and minimum values of the function. So in order to look at what the periods begin at any point on the graph and then trace one complete pattern. The beginning and ending x values of each cycle determine the period of the function. So we could say f of x is equal to f of x plus the period. And that could help us find other values of a function, but that tells us one period. So determine if the graphs below are periodic. If they are periodic, then determine the period and find f of 11. So looking at A, so remember something that's periodic has to repeat at y values at a horizontal interval. So looking at A here, we don't get a repeating pattern horizontally, so this is not periodic. Looking at B for this one, this would be a periodic function, and if maybe we start here to kind of look at the pattern, we can see that if I were to move this shape over, it would continue over here. So this would be a periodic function. Did I have to start there? No, I could have started at somewhere else on my graph, but this one's the easiest place because then we can look from y all the way over to here to see what the periodic function is. It looks like our x-axis scale is going by 2s. So since it's in the middle, it looks like that is 7. So this is the periodic. And the period of the function is 7, which I often abbreviate as PD. And so if we want to find f of 11, so f of 11, we would take f of 11 and we would subtract it from the period to find an equal point that has the same y value. We're just doing this equation right here. So f of 11 is equal to f of 4, and on our graph, if we go to an x value 4, so 1, 2, 3, 4 would be right here, that means that is equal to 0. And we can do that for any values. Looking at C, again, we're looking to see the horizontal length of one cycle of the repeating pattern. So for this one, again, you can start these anywhere. So it looks like the easiest place to start with this one would be here. And we can see then if I take that pattern and move it over, it would be repeating. So what is the distance of this? Again, it looks like our x-axis is going by 2. So this would be -2 here. So this is -3. And that goes all the way to, let's see, 2, 4, looks like 5. So the distance would be 5 minus -3, which would be 8. So yes, periodic. And the period is equal to 8. So if I want to find f of 11, that would be equal to f of 11 minus the period, which is 8. So that means that's the same of f of 3 in our graph. So if we find f of 3, which is in between 2 and 4, it looks like, this one's kind of hard to see, but it looks like it hits about right there in the middle. So the y-axis is always also going by a scale of 2. So it looks like it is equal to 3. It's difficult to see on that one though. And then for D, this doesn't have a horizontal distance that it's repeating because it just keeps getting higher and higher for the y value. So this one is not periodic. So that's it for our periodic functions. And now we're going to talk about graphing sine and cosine, which again we did last year. So this should be a review of what you learned last year. The graphs of sine and cosine functions are periodic. We have learned that the sine value of a function is equal to the y value at the corresponding point or angle in the unit circle. Also, the cosine value is equal to the x value at the same point or angle. The graphs of sine and cosine look like waves, and they're called sinusoids. To sketch the basic graph of a sine equation by hand, it helps to note the 5 key points in one period. So the key points are the maximums, the minimums, and the intercepts, or where the graph crosses the midline if we have transformations of the graph. So to find the key points, you take the period of the function and divide it into 4 equal parts. So the key points are the period divided by 4. So sine and cosine, if you recall, all the way around your unit circle would be 2 pi. So that means the key points are going by intervals of 2 pi divided by 4, which is equal to pi over 2. So we use that for the units on our x-axis scale when we're graphing. So over here, notice that I'm just using the key points on our unit circle. So if we think about sine is the y-coordinate. So think about where your maximums, your minimums, and your intercepts would be. They would hit here, 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 and here. So thinking about the y-coordinate, so 0 would be at 0. So the sine of 0 is equal to, 0, I wrote 1, so the sine of 0 is 0. The sine of pi over 2, because this is pi over 2 if you crawl up here, is 1. This is pi, so the sine of pi is 0. And the sine of 3 pi over 2 is the y-coordinate again, -1. And back to 2 pi or back to 0 would be equal to 0. So those are the values that we are going to be graphing. So you always want to label your x and y axes. So I'm going to label this as 1 here and -1 here, just so we have more room to graph. So on my graph, when I graph this, I start at 0, 0. Then pi over 2, the sine of that is 1. The sine of pi is 0, 3 pi over 2, -1, and the sine of 2 pi is 0. So this is what one wavelength of our sine graph looks like. We can see the maximum's 1, the minimum's -1. So the domain for this is going to continue because we can keep going around and around our unit circle. So all real numbers. And the range is bracket -1 to 1. And so we can also do this with our cosine graph as we learned last year. So cosine is the x-coordinate on the unit circle. So the sine of 0 in this case would be now equal to 1. The sine of pi over 2 is 0, -1, 0, and 1. So that gives us our cosine wave. So at 0, we have 1. Pi over 2 is 0, -1, 0, 1. So another way you can help you remember this, we hit the origin or the midline. We go high origin, low origin. And for cosine, it was, we started off at the highest point or the maximum, origin, low, origin, high. So that's what our graphs for sine and cosine look like. So hopefully you remember those from last year. The midline is the distance between the maximum and minimum value. So for both of these, we can see that the distance from our max to our min is a distance of 1 from the amplitude, but the midline is going to be in between. So it means this would be 0 for these, and the amplitude is going to be 1. So normally for the midline, since it's a line, we're going to write y equals 0. And the frequency of the trigonometric function is the number of cycles it completes in a given interval. So in this case, the frequency would be equal to 1 over the period. So 1 over 2 pi would be equal to the frequency for these graphs right here. So those are our basic graphs. And now we're going to look at the transformations. So the general sine equation is a sine x plus d. So the sine has symmetry with respect to the origin. So that means that this is going to be an odd function. So that means that the sine of -x is equal to the negative sine of x. And remember that A stands for the amplitude and D is the midline. And we're not going to talk about the B value today or moving left or right. We're going to talk about those in a different day. So we're going to graph each function and identify the key points and state the domain range and all the information that we have here. So here we can see that our amplitude is always a distance. So we are going to do the absolute value of our A, which is -3. So the amplitude is equal to 3. Then we have our midline, because that's our D value, which is right here. So the midline is equal to 1. And the period we're not changing for these. So the period is 2 pi. And our key points are then to take the period divided in 4 equal parts, 4 pi over 2. And so for our graph, we want to label our x-axis with our units that we're going by, which are the key points. So the key points go by units of pi over 2, and you have to know how to do this for when we change the period. So you always want to write down each x-axis key point. It's important. So 1 pi over 2 doesn't reduce, it's just 1 pi over 2. And we have 2 pi over 2, which reduces into pi. 3 pi over 2 doesn't reduce. And then we get 4 pi over 2, which is 2 pi. So that's our first cycle. We're going to keep going. Next one would be 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2, 11 pi over 2, and 12 pi over 2. So if it helps you to write them up there and then reduce them on the x-axis, that's fine. So 5 pi over 2, this would be 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, 5 pi, 11 pi over 2, and 6 pi. And then we're going to do a negative cycle as well. Okay, so then on my y-axis scale, this is just 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So now that we have our scale down, we can go ahead and start to graph. So if it helps you to write all the transformations out for the graph, that's fine, but we don't really need to now. But I'm going to go ahead and just look at our first one. So this is the sine graph. So if I think about the sine graph on my unit circle, we just graphed the parent graph. We know it starts at 0. So it starts here at 0, 1, 0, negative 1, 0. So if you want to graph each transformation out, and then graph the final graph, that's fine. So then what are we doing next? We have a reflection across the x-axis, a vertical stretch by 3, and then we're moving it up 1. So then reflection across the x-axis means this would go down this way. Vertical stretch by 3 means that our points would then change to here. And then we change the y coordinates, and then we would move that up 1. So instead of doing all of those transformations now, I like to graph this just thinking about using my midlines. We already did our x-axis points because we don't have any horizontal changes to our graph. So when I graph these, what I like to do is I'm going to draw in the midline first, which is at 1. And then once you have the midline in, we can go ahead and say, okay, well, sine always starts at 0. We're moving it up 1, so now it starts here. And then our amplitude means we're going to go up and down from the midline 3, but instead of going up first like we normally do because it's negative 3, we're going to go down 3. Back to the midline, up 3, back to the midline. So that gives me my first wavelength with my transformations. And then I could keep going. So down 3, back to midline, up 3, back to the midline. So this would be a second cycle or a second wave. And then I can do a third wave. So now I have 3 waves shown. And if I go the opposite negative direction, I just go back the other way. So this will just go the reverse around our circle. Notice that our graph looks like waves as we go around. So from here to here is the first cycle. And we have another cycle here. This would be the second, etc. So we have 4 cycles shown. We can see our maximum's at 4 and our minimum is at -2. The domain's all the numbers because we can go an infinite amount of times around our unit circle, and the range in this case would be from bracket -2 to 4. So your minimum to your maximum value. So now we have our graph. So again, you want to use the transformations or just graph it like this, that's fine. However it works for you, best is okay. So now we're going to graph this next one. So same thing, we haven't changed our b value to change the period for these graphs. So 2 pi, so our key points are still going by pi over 2. So I'm just going to write the same ones we had above. So pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, 5 pi, 11 pi over 2, and 6 pi. And again, that's just from above. So then the amplitude, in this case, the absolute value of 1/2 is just 1/2. The midline is our d value at -2, so this is our A and our D. So when we're graphing this, I'm going to start off with the midline. So the midline's at -2. So I need to put my scale here. I would take my midline at y equals -2, would be right here. And so again, this is sine. So sine starts on the y-axis on the midline. And we don't have a reflection, so we're going to start here, and then we're going to go up 1/2 from the midline, back to the midline, down 1/2, back to the midline. So that would be my first wave, and then we're going to continue to repeat that pattern. So up 1/2, back to midline, down 1/2, back to the midline. So that would be a second cycle, and then a third cycle. Of course, we could also do a negative cycle. That gives us 4 cycles on our graph. We can see that the maximum is at, let's see, maximum is at negative, what's that, 1.5? And then the minimum is at -2.5. So the domain's all real numbers, and the range goes from -2.5 to -1.5. And so that would be our graph. And again, if it helps you to do all the transformations starting from the parent graph and then doing a vertical compression by 1/2 and then moving it down 2, that's okay as well. So now we're looking at graphing cosine. So when you're graphing cosine, again, A is the amplitude, D is the midline. The cosine graph has symmetry with respect to the y-axis, which makes it an even function. So that means that the cosine of -x is equal to the cosine of x. If we go back up here just to look at our sine graph, so notice that your sine graph here, it's an odd function because if you have the point xy in your graph, you would have the point -x, -y, and cosine, you could fold it in half on the y-axis. All right, so for this one, we have, again, we're not changing our b value to period. That would be here if we were. So it's still 2 pi and pi over 2. The amplitude is the absolute value of -3, which is 3. The midline is at -1. And I put the x-axis key points down first so we don't have to write them again because it's just the same as the ones we just did. But again, if they're not written, you always want to make sure to write those in. So we're going to start at -1 for the midline. And so what are we doing? We're doing a cosine graph. So cosine graph, remember, starts up here normally, goes to here, 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 here. So 1, 0, -1, 0. So that would be the parent graph. So instead, we're not starting at 1. We're going to be thinking about our midline. So at our midline, normally we would start up, but because we have a -3 here, we're going to start below the midline, down 3, 1, 2, 3. And then you go to the midline, up 3, back to the midline, down 3. So this would be my first cycle of my graph. And again, if it helps you to graph the transformations and then get to this graph, that's okay as well. So this would be my second cycle. We're just repeating those values. So back to the midline, up 3, back to the midline, down 3. So the transformations for this would be a reflection across the x-axis, vertical stretch by 3, and down 1. So this gives me my 4 cycles of my graph. We can see that our maximum is at 2. The minimum is at -4. Domains all real numbers. So bracket -4 to 2 would be the range. Looking at the next one, we have, again, the period is 2 pi. Key points would be pi over 2, which is already on your graph for you. The amplitude is absolute value 3/2, so just 3/2 or 1.5. Midline is 2, so my graph, I'm going to draw my midline at 2. So 3/2 is 1.5, so that'd be a vertical stretch by 1.5 and then up 2. So cosine, again, because there's no reflection, we can start up 1/2 from the midline. So we're going to go up 1/2, which would start us right here. So that means our maximum is going to be at 3.5. And then we would go to the midline, down 1/2. So down 1.5 would be here. So then 0.5 is the minimum. Back to the midline and up 3/2 or 1.5. So that's our first wavelength. And then we can continue that pattern to get a second wave and a third wave and then a fourth wave. Again, I don't expect you guys to have to do the transformations anymore, but if it helps you to do them, you can. Domains all real numbers, and the range goes from 0.5 to 3.5. So now we have our cosine graphs. So next we're going to look at the general equation for sine and cosine. So we have the amplitude is the maximum minus minimum divided by 2. Remember, it's always an absolute value of that. Midline is maximum plus minimum divided by 2. Think about midline as your average. And then the key points are the period divided by 4. And then if A is bigger than 1, it's a vertical stretch. If it's in between 0 and 1, vertical compression. And if A is less than 0, we reflect it. So now we're going to write the equation of the graphs below using the max and min to help us. That's where I always start. So for this first graph here, we can see our maximum is at 2 and our minimum is at 0. So then I'm going to find the amplitude next, which is the maximum minus the minimum divided by 2. So in this case, the amplitude is equal to, I guess I just write equals. So we have 2 minus 0 divided by 2, which is 2 over 2, so 1. My midline is the maximum plus the minimum divided by 2, because again, think about it like the average. So we have 2 plus 0 divided by 2, which also gives us 1. So I'm going to draw that midline in here, and then you can even visually see if I go up 1 for the midline and down 1 for the midline, that gives us our amplitude. And we haven't changed the period. So if you look at, we always count the 5 key points. When it does change, you're going to want to know how to do this. So this would be 1 key point, 2, 3, 4, 5. So key points are the maximum, minimums, and where it crosses the midline. So notice that one wavelength would be from 0 to 2 pi. So the period hasn't changed. It's still 2 pi. So how do you find the b value in your equation? We always use b times the period equals 2 pi, if you recall from last year. So to solve for the b value, which we haven't really talked about yet, but I'm going to write the general equation. Did I write it up here? No, without the b. I'll write the general equation with the b in just a second. The b would be equal to 2 pi divided by the period, because you're just dividing the period on both sides here, which would be divided by 2 pi, which is 1. So again, we haven't changed the period. So the general equation with the b value is y equals a times the sine of bx plus d. But again, we haven't changed that. So that's why we're not worrying about it right now. We'll worry about it later. So how do I know if this is a sine or a cosine graph? So the way you can tell is that sine graphs start on the midline. So, and in this case, since we haven't done any phase shifts, we're going to start on the midline on the y-axis. So in this case, because it starts on the midline on the y-axis, I know this is a sine graph. So now I can go ahead and write the equation. So my equation would be y equals the sine. Since our amplitude is 1, you don't need to write that 1 in front, but if you want to write the 1, you can. So 1 times the sine of x plus 1. So that gives me the equation of my graph. Let's do the next one. So for the next one, same thing. So we have our maximum, which is 1, the minimum, which is equal to -3. And so the amplitude is the maximum minus the minimum divided by 2, which gives us 4 over 2, which is 2. The midline is the maximum plus the minimum divided by 2, the average again. So this would be -2 over 2, which is -1. So if I draw my midline in here, I can count up 1, 2 for the midline and down 1, 2 for the midline for my amplitude. And so then notice that our graph on the y-axis is not starting on the midline. We're starting above or below. So cosine starts above / below midline on the y-axis. So this is below instead of above, because remember that the parent graph for cosine only looks like this. So because it starts below, that means it does have a reflection across the the x-axis, sorry, reflection across the x-axis. So the general equation, y equals a times the cosine of bx plus d. And if we count our 5 key points, 1, 2, 3, 4, 5, notice that the period is still equal to 2 pi. So b times the period equals 2 pi. So that means our b value is equal to 1, which we are not changing until a different lesson. So then we have our amplitude, we have our midlines, we have everything we need. So we have y equals, the amplitude is 2, but because it's going down first instead of up starting, we have to put a negative in front times the cosine of x. And then our d value is minus 1 because our graph moved down 1. And so again, this was cosine. And so that is all for our periodic functions and graphing sine and cosine, and then also writing the equation given the graph.